All right, in this video I'm going to show you about the simplest Arduino project I've ever done. And it came about, my students wanted to create a caroling robot, and so we had to work with with the piezo buzzer and figure out how to make a song out of that. And so we were able to do that, make a song, and maybe in a later video I'll show you that project and how it all came together. But for now we'll keep it simple. So all you need are a couple of wires. I'm using an Arduino Uno and a piezo speaker, or well, it's just a buzzer. And I'll pull this out. You can see it has two prongs for the wires, the positive and negative. And it doesn't matter the polarity. You can hook it either way. This isn't a diode, so it can be it doesn't matter what direction the electricity is going. So I'll stick this in the top row, and so you can see these are kind of plugging these into these mini breadboards is kind of a pain in the butt, but you can see I plugged it into this row. I don't know, that must be a J or something right there, but along this top. And that just barely gives you enough room to plug into the positive, which will be right here, and the negative, which is right there. It took a long time for us to figure that out. It's probably the hardest part of the project. And then you just need to find a ground, and you can hook it to either one of those sides. So I'm going to hook it to this closest ground here on the Arduino board and hook it in there. And it's not a very good pin. It'll push that piezo out. The piezo has some kind of rough pins in it that are short and they don't work real great. And then I'm going to plug the other one. You can see it'll be the first hole that's available. I'm going to plug the other one into pin 8 on the digital pin 8 on the Arduino. All right, and that's it. This thing is wired and ready to go. And I've already preloaded the program, and I'll show you the programming of it, but I have a little DC jack. I'll just put some power to this thing, and you can hear it running. So, there's old Macdonald. It's not really a great sound, but works pretty good. We did a whole bunch of different songs. And let me show you the process for programming this. So that's the build, and that's how easy it is. But the first thing I had to do was find a song. And here's Old Macdonald. And what I did is I just did a Google search for it. Old Macdonald Had a Farm. And this one actually came from www.makingmusicfun.net. There's just a little shout out to that website for providing this for me. And it has treble clef and bass clef. So I'm going to get my melody off the top, which is the treble clef. And this is in 4/4 time. And each note, you got 4/4 notes, and I number them all the way to 50. I think there's 57 notes in this thing. And these here are called quarter notes. So you got quarter, 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 half. And maybe if I zoom in, you can see that. And down below, I've labeled them. So I numbered on top for my programming purposes and labeled what the note is down below. And I'll explain this note, and then the number beside it is the octave. And I had to teach this to my students. This is a half note. These are all quarter notes. This is a 3-count note. It's a dotted half note, which you'd play this each bar is 4 counts. So you'd play this for 3 counts and then a quarter note. And the only other one you need to know is these right here are 1/8 notes. And then you can see a set down here below. Those are all 1/8 notes. And I've numbered all of these and labeled all these. I guess I didn't towards the bottom because I was getting lazy. The other thing is there's rests in here, and in this part of the song I did play the bass clef. Let me pull that up there. So where there is a, I only let it, this is a rest for one measure, 1/4 note rest, and then it was a whole note rest. Well, I just had it play these notes in the bass clef with a rest, and you'll be able to see that in the programming. But to decompose the music, what I did is I looked up treble and bass clef, and you can see I've listed this note here as an E4, which means it's an E in the 4th octave, and it's 330. Well, that's the frequency. Well, what's kind of cool is if you vibrate something at 330 hertz, it will produce this E in the 4th octave. And then you can see this one's G4, and that's the 392 hertz is the vibration. So that buzzer is vibrating at 392 beats per second, and that's what creates the G4 tone. And so where I got that was, it was real easy. I just looked up frequencies and the physics of music, and here's the site I got it from, the physics of music, and then physics of music and notes. And this is the scale in where A4 is a 440, and you got different choices, but I just went with the 440. And you can see the E4, like that E4 I was looking at is right there, E4 329.63, and I think I rounded it to 330, but on the rest I didn't round them. And so that's where we get into the programming of this. So the first part I have, this is above, you've got your void setup and void loop. Above that void setup and void loop, I made some global variables. So I started out with a whole note equaling, and that's 1800 milliseconds. Half note is 2 counts, so it would just cut that in half. Quarter note is 1 beat, so it cuts it into quarters. Eighth note, you cut it into eighth, the whole note. 16th note into 16th. And then I put in a delay between notes, otherwise they all run together. And that's going to be, I just set it at 20 milliseconds. And you can adjust these, by doing it this way, you can adjust that whole note to speed the song up. You can adjust the delay between notes, things like that. You could probably get more complicated. And then one thing I learned the hard way was you always set up an integer for the pin you're using. So I let treble, for treble clef, equal pin 8. So that's going to be my pin number. Then I went through and I set up all of my bass clef notes from G2 to G3. And again, let me show you where those come from. Here's the bass note clef. So here's G2, it's a 98. B2 is 123.5. D3 is 146.83. And it's 123.47. You could, I've used it with just whole notes and used integers. All the way up to D4. And you can get these all off of there, off of that physics page. And this is a 220 for A3, and then on down to A2 is 110, and so on and so forth. So there's your bass clef. And so I just put all of those in right there. So those are all of the bass note clefs all the way to G3. And then in between the clefs, you've got this AA3. Well, that's the A, note A, in the 3rd octave. But you can't, if you just have an A3, that's the analog pin in Arduino, and so that variable is already being used. So I just changed it to an AA3, and I've done that everywhere. And then here's the treble clef, and I used floats for all of them, so it's 329.63. You could also do integer int and round it to the nearest, so this would be a 330, and you still get pretty good sound. notice again, instead of A4, I have AA4. Okay, so then that's all the global variables for the notes. And then your song is really easy. So here I just label my very first note. It's going to be tone. Treble means pin 8. So it's going to tell pin 8 to play the G4 to play that many hertz. So G4, if you look up here, G4 is 392 hertz. And it's going to play that for a quarter note, so a quarter of the time. And then it's going to no tone that pin 8. It's going to tell pin 8 to shut off. And then we're going to delay between notes, which was that 20, delay between notes is right here at the top at 20 milliseconds. And then we'll go on to note 2. Treble, G4, quarter note. It'll do no tone, treble. So this no tone, pin 8 at the G4 again. And then it'll go here to the 4th note, which is D4. So, you think about old Macdonald, that it goes down on that 4th note to the D4. And that's how you just do it all the way through. If you have a quarter note, it's quarter here. If you have a half note, it's half here. You just change this variable if you want a half note. And it's fun to play with this. It is a lot of fun. We've created a lot of music with this thing. I just did Old Macdonald because it was easy to find the notes for, or the music for. But that's where I'm going to end it. And I'll let you play with it. I'm going to create a blog on this eventually, and I'll stick that in at the end of here eventually if this is popular at all. But you can see I have, if you go to the bottom, I'm scrolling towards the bottom of this thing, I have 57 notes. It won't let me do the whole thing. And I put all of those notes in the void loop. And so it'll just keep looping every time. And I put a delay of 1,000 at the bottom so when you hit the end of the song. So it'll stop for a second and then start playing over again. And we've put up to 6 songs, little short songs. Rudolph the Red-Nosed Reindeer. We did a whole bunch of basic Christmas music one year, and the kids really had a blast making the songs and turning music. That's what's so cool about this. A real simple. If you've got the music, you've just put music together with your technology and mathematics and physics, and just how fun is that? That's amazing stuff. So good luck. Hope you can do the same, and see you next time.